All right, hi ladies. In this video, we're going to go through 5B, modeling practical situations. So in matrices, they're used to not just put random numbers into square boxes, they actually model practical situations. So let's have a look at a few examples. So a network diagram of points. So when we do networks, okay, the points are called vertices, are joined by lines which are called edges. Okay, so in matrices, you don't really need to know those definitions, but they're there. So you can refer back to them if you need to. Okay, so that's a network diagram. It can be used to show connections or relationships. A matrix can be used to represent a network and solve related problems. So there's a relationship between networks and matrices in that a network can be represented by a matrix, and a matrix at times, depending on the context, can be represented by a matrix. Okay, so first example, the following is a network diagram that shows the way to travel between three towns A, B, and C. All right, so first of all, you're probably not familiar with networks. You probably didn't do it in year 10, so this might be new to you. I'm going to have to do this, oops, wrong one. Let's just get rid of that, sorry. And I'm going to do it in a Word document. You just go away. Let me just delete all that. I think I'd be a little bit more organized than that. Okay, so your matrix, to be honest, I didn't think I would be doing any working out, but this one you can't get around. Okay, your matrix is going to be A, B, C for your rows and A, B, C for your columns. And matrices always have square brackets, so make sure you've got square brackets. Now, first of all, this element here, AA, basically says, well, how many times is A connected to A? Now, we've got A not connected to A. A would be connected to A, and I'll show you the situation when it would. So if this was A, it would only be connected if we had what is called a loop. There is no loop here. So this is 0. A is not connected to A. How many times is A connected to B? We've got 1, 2. So I can write 2. How many times is A connected to C? It's 1. Now, the good thing about this is it's symmetrical. So I can write 2 and 1 here as well. And I can also see that B and C, C has a loop, but B doesn't. Okay, so no loop at B, but C, this big loop going around here, that gives you a 1. Okay, so there's a C there. You can go from C back to C without having to go to B or A. All right, so let's now finish this row here. So B to C, B can get to C 2 ways, and in reverse, C can get to B 2 ways. Okay, so you can see it's symmetrical along the diagonal. So the diagonal is your separator. Okay, so we've got 1 there because there's a loop at C. All right, so I've done question A. I assume I can't read the whole question. All right, use the matrix to find which town has the most ways of traveling to or from it. So you can kind of see, if we just go back to the diagram, you can see that A has 1, 2, 3 ways of getting to it. So what you can just do is add up your rows. Okay, so there's 3 ways. B has 4 ways. So it's got 2 ways from A and 2 ways from C. And then C has also 4 ways. So it's got 1, 2, 3, and then it can come back to itself. Now, I might just check the wording of that question. Which one has the most ways of traveling to or from it? So I would say traveling to C from C is not a way. So I would answer B. But quite a silly question because there is a loop there. Okay, is there another question? Oh, good. Well, that's it. So girls, even though we've just done one example, if you have any questions about chapter 5B, please let me know. Okay, bye.